The first type of logarithmic equation we're going to solve is the easiest type, which is what we call a one-to-one correspondence. Kind of like what we saw yesterday with some of the exponentials. If it's like 5 to the x equals 5 to the third, and because the bases were both 5, then the exponents have to be the same, right? So we set an equation up with the exponents. Here, same logic. Okay? If I've got log base 2 of some argument equal to the same log with the same base in an argument, the only way that the left-hand side and the right-hand side can be equal is if what's in these parentheses are equal, right? Does that make sense? So all I'm going to do is take 4x, set it equal to x squared. And when I have a nonlinear equation, how do we solve nonlinear equations? Nonlinear polynomial equations. What should I get everything equal to? 0. So that tells me I should be doing what? I subtract it, but what's the overall process here solving for x? Taking out an x, which is called factoring. Okay, so nonlinear polynomial equations, no matter what the degree is, you're going to factor them. So here we get x to be 0, and we get x to be 4. You guys agree with that? Okay, now, when we work with logarithms, we always have to think about extraneous solutions, because a logarithmic domain, the domain for any logarithm, is going to be numbers that are bigger than 0. You cannot take the log of a negative number. You cannot take the log of 0. Because if I take log, just say base 2 of x, what's going to happen is you're going to have an asymptote right here on the y-axis. Meaning x cannot be plugged in, x cannot be 0 there. Okay, because you never get to the y-axis, right? And x cannot be negative because there's nothing over here because the asymptote restricts your graph. So, when we are done with all of these, you need to go back in and check to make sure that you don't have extraneous solutions. So if I plug 0 in, I get log base 2 of 0 here. That's a problem. Okay, cannot evaluate that. It's undefined. So x equals 0 is an extraneous solution. If I plug 4 in, it works there, right? I get 16. I got to check it everywhere. I got to check it in every logarithm, though. So do I get 16 there as well? And my hope is that once you do that, you can see is for the value that when I plug it in, it satisfies that equation, makes that equation true. It's the only number that does that. Is that okay? So that's the easiest version of a logarithm. When the bases are the same, you set the arguments equal to each other and you solve the remaining equation. Now that equation, that can be anything. Okay, that equation is all dependent on what your arguments are, right? So that equation, maybe that turns out to be maybe quartic, and you have to use like P over Q and the rational root theorem and all that kind of stuff. Maybe it's quadratic, and you have to use quadratic formula. Maybe it's quadratic in form, and you have to use U substitution. Maybe it's rational, and you have to use all those processes and multiply by the LCD. Okay, so this generated equation will be one of any type of equation that we have seen and hopefully mastered since Algebra 1. Okay. The next type, a little bit different, because now, we're going to do this bottom one first. Now we don't see logarithm written on both sides, right? And I think that last one was almost trivial, pretty easy to do. This one is about the same. This is not all that complex. These are the easier versions of these types of equations. When you see logarithm written one time, what you have to do is first isolate it. Okay? Because I'm going to use inverse operations. So if I had like an x squared in a problem, let's say I had like x squared plus 3 equals 12. What do I do to solve for x squared, or to solve for x first? Subtract 3, right? Why do you do that? So you can isolate the variable, because the next thing you're going to do is take square root, right? Which the square root is the what for x squared? The inverse, okay? So all of our equations that we've seen all year long and all through algebra, okay? If you're going to use the inverse operation, you have to isolate that term that you're going to use the inverse on first. Does that make sense? Okay. So here, if I'm going to use inverses, I need to isolate my term. That's already done here, but if I had something like maybe 2 plus log of 25 minus x equals 3, if that was my problem, I would need to move that 2 over before I did anything. Does that make sense? Okay. But once your logarithm is already isolated, now it's just a matter of applying the definition of a logarithm. The definition of a logarithm says that if I have a log base a of x equal to y, if and only if a to the y equals x. Yesterday we started with the right-hand side working with exponential equations. And we had to apply the definition to solve for the variable by changing this right-hand side into a logarithm, right? Today it's the reverse of that. We're going to start with the logarithm version, and we're going to change it to an exponential so that we can deal with the variable, okay? This variable in here, it is stuck in the argument. It's much like if I had this. If I had that equation, can I just start subtracting 25 from both sides or adding x to both sides right away? No, I need to get rid of that root, right? How do I get rid of the root? Square it. I use the inverse, correct? Okay, and that will unlock this radicand. So, how do I unlock this argument here? Is I use the inverse. The inverse is the exponential. So what we're going to do, okay, I like to write especially with these equations, write the version of the logarithm definition that I'm dealing with above the problem or below the problem. So I can see what a is. My base is 2, right? So when I go into exponential, I know where that 2 should go in that format. So a is going to be raised to the y. So I come over here, my y matches up to the 3, correct? So 3 should be there. And now on the right-hand side is x, which x is represented by, in this problem, 25 minus x. Okay? Now, you can do it that way. I do it that way sometimes. I prefer, I've done it long enough that I know I can take 2, raise it to the third, come back to my argument. That's kind of that picture we've been dealing with in other, like evaluating logarithms. Okay? So now do you see that kind of broke that 25 minus x out of that argument? And now we're going to solve for x. We get x to be 17. Is that okay with everybody? If x is 17, I'm just going to check real quick. If I put 17 in there, 25 minus 17 is 8, right? Is this true? Does 2 raised to the third power come back and give me 8? Yep. So 17 is my confirmed answer now. Does that kind of make sense on how to do that? That's not that bad, right? Okay, take the logarithm, transform it into an exponential. The first one there, ln of x equals 8. Okay? People kind of wig out on this one because they don't know what to do because it looks different than what we've been doing. But what did we talk about ln being yesterday? Log base e. So I'm going to rewrite this. Log base e. I'm going to replace ln with that right there. I'm going to put my x on and equals 8. Now, is this just like the problem we just did? Yeah. We're going to take my base raise it to my exponent of 8, and it comes back and gives us the argument. And when we do that, it creates a trivial equation. It's already solved, right? Mm-hmm. So I don't need to go through any other calculations. I know what, or operations. I know what x is. It's e to the 8th, which should make sense. Yesterday we had a rule yesterday said ln of like e to the 8th, okay, because that's what x is. Think about what that means. ln is log base e. So we'll put that e to the 8th there. Does it make sense that e raised to what number will come back and give me e to the 8th? What does this number have to be over here? It has to be 8, right? Is that what, when we choose x to be e to the 8th, is that what we get right there? Get a true statement, right? Are those logarithmic equations things that we could do? You feel comfortable with those? If you can remember that procedure, all the other ones that we're going to do here, which I think are more difficult, all get to that point. Okay, so we're going to have a step or two steps that we're going to transform an equation so that we get down to something like this, so that we can use the definition. Okay, regardless of the logarithmic equation, if you see the word logarithm multiple times, okay, and it's not, here we saw it multiple times, but there was nothing else here. Okay, so if there's like a +3 or some other term on here, we could not have done what we did here in this problem. Okay, those types of problems that look like maybe something like this, we have to do one step before we can get that transformed into what we just did. Okay, I know it's maybe wordy, explain it that way, but you'll see in this example that kind of played out. Got a logarithm written twice, right? And this could be provided several different ways. You know, maybe this problem started off as log of x minus 5 equals 1 minus log base 9 of x plus 3. Okay? And I just want to draw a comparison to this and what we've already done, because the first problem we did, we said, well, if log shows up on the left and it shows up on the right and it's the same base, we just take the arguments and set them equal to each other, right? Here we can't do that because it's not just the log base 9 on the left and just log base 9 on the right. There's a 1 minus on the right hand side, right? So you can't do it that way. So if that's the case, okay, if you have multiple words, multiple logs written, and they're always going to be the same base, okay? If we change the base from 1 to be 9 and 1 to be 7 or something like that, that's outside the scope of this course. So they're going to be the same basis. If I want to do this problem, I need to get all my log components on one side. Okay, so that's kind of where we're starting off here in this type diversion. All right, so we get both logarithms on the same side. Now we're going to apply what we talked about yesterday. There's 3 properties. One of those properties is if I have the log of some base of A plus the log of the same base B. You guys remember what that turned into yesterday? What do we do with that A and that B? Multiply them. Okay? If it was subtraction, we would divide them. But here, because it's addition, we're going to multiply them. So that's kind of what we're starting with. If I highlight the left-hand side of that blue phrase, if we look at that right there, does that format match to what we've got right there? Okay, where this x minus 5 is kind of the A argument, and x plus 3 is our B argument. So what we're going to do is we're going to rewrite it as log base 9 of A times B. So x minus 5 times x plus 3. Is everybody okay with that? So using that property, now how many times do you see log written in your equation? Just once, okay? So it's written just once. Now we can use the definition of a logarithm. I'm going to take 9, my base. I'm going to raise it to the first power, my exponent. And that should come back and give me this argument of x minus 5 times x plus 3. Is that okay with everybody? Okay. What type of equation is that? It is quadratic. Good. Okay. It's not obvious. It's not expanded, but that is a quadratic equation. If I have a quadratic equation, how do I solve that? Okay, so we're saying we're going to multiply this out, so it's going to give me minus 2x minus 15. And I still got this 9 over here, right? What do I do with that 9? Yes, I got to make it 0. So I subtract it from both sides, and I get that, correct? What I want to make sure that we understand, and this happens every year I give this question, is the number one response I get is x minus 5 equals 9, and x plus 3 equals 9, and if we can solve that. You cannot do that, right? If we're solving quadratic, we have to have the zero product property, which says if the product is 0, you automatically know one or both numbers are 0, right? If I say the product is 9, does that narrow your focus on what one of those numbers have to be? What are two numbers that multiply together to give me 9? 3 and 3. So one person can use 3 and 3, right? What's another option? 1 and 9. So another person, neighbor, can use 1 and 9. What's another option? 4.5 and 2. Okay. What about 18 and 1/2? What about 81 and 1/9? Right? There's an infinite number of factors. Okay, and it might not be integer factors, but there's a infinite number of factors that multiply together to give me 9. So that doesn't help me narrow my focus on what the two x values have to be. But when that's 0, that does narrow our focus, right? This is a zero product property. So you got to make sure that you do that. So now this is going to go to x minus 6 and x plus 4, right? So then x is 6 and x is negative 4. However, when we do this step right here, we introduced a power of 2 now. It's kind of like when we went back to like solving radical equations. When we solve radical equations, we have to square things, right? When you introduce the squaring function, you create sometimes extraneous solutions. Extraneous solutions they arise in this situation as well because of that multiplication that happens. We just want to make sure that when we plug our x's back in, if I plug x to be 6, is it okay right there? Is 6 minus 5 okay? What kind of numbers am I looking for in my argument? That gives me 1, and that's okay, right? I'm looking for positive numbers in my argument, right? If I plug 6 in here, it gives me 9. I'm okay with that, okay? And think about it, you know, if I actually said log base 9 of 1 plus log base 9 of 9, does that equal 1? What do I raise 9 to get 1? Say it again. 9 raised to what power gives me 1? 0, right? So that number right there is 0. What do I raise 9 to get 9? 1. Does 0 plus 1 equal 1? Yeah. So that's why 6 works. What about negative 4? I cannot have a negative underneath or inside the argument here because that would give me log base 9 of negative 9. And there's nothing you can raise your base to give you a negative number. There's no way to generate a negative 9 by using just exponents from 9. Does that make sense? Okay. Some people might say, well, I can use negative 1. Because 9 to the first would be positive 9, right? So they say, well, 9 to the negative first should give me negative 9. What does 9 to the negative first really give you? 1/9, right? Okay. So this cannot work for us. That is not a solution. Yes? I knew that was. I always think that maybe you can contribute to class, but then you leave, and that's even a greater contribution. So yes? Oh, you're going to miss the best problem of the day. Yeah. What do we do here? Nothing? Skip it? What's addition mean? Okay, so this turns into ln of x minus 1, x plus 2, right? Okay, equals 1. Now, some people, it doesn't matter. We could talk about this in the last one as well. Some people right away just rewrite this as ln of, and then they know that those are going to get multiplied together, and they know that they're going to have to go, x squared, what's it going to be, plus x minus 2 equals 1. Is that fair? You can either expand it now, or you can expand it after you apply the definition of logarithm and get rid of that ln. But regardless, you got to expand that x minus 1 times x plus 2 at some point, right? Any ideas what we do now? Like, what do I... Good. Okay, so people get frightened with this because ln is different. It's kind of bizarre. But we rewrite it as log base e. And that looks just like the problem we did before, right? Last class I kind of made the argument, don't let notation scare you. It's like people that go in, like you might have like an A in an English class and be very good at English, but then you go into your English class and you're going to read Shakespeare. Is Shakespeare different than all other, like, maybe types of books or plays or whatever you've read in the past? Like, is it, yeah, it's a different kind of way of understanding what they're talking about, right? Is it still English? 100% still English. You still read it, okay? So when I talk about ln, it's different. Kind of like Shakespeare's a little bit different, right? But it's still logarithms. I can still do the work if I make that kind of substitution, okay? I don't know if that's a great analogy, but don't let ln frighten you, okay? Change the log base e and then apply everything else the same way. So I'm going to use my definition of a logarithm and take that base, raise it to that power. So e to the first. And that should come back and give me x squared plus x minus 2, right? What do I need to make e to the first in order to solve for x? Got to make it 0. So I'll subtract e from both sides. Now e, it is not a variable. That's 2.7. Okay, it obviously goes on forever. That's an irrational number. Okay, so I need to subtract that e from negative 2. Does that make sense? Well, because it's irrational, I don't want to subtract like 2.7. I don't want to subtract 2.71 because no matter how far out I go, I'm cutting that off and I'm going to be inaccurate, right? So I'm just going to subtract e. So negative 2 minus e. Is that okay with everybody? Okay. Now, does anybody know two numbers that multiply together give you an irrational number but add to give you a rational number? No, we don't think in terms of irrational numbers and multiplication, that kind of stuff, right? So what would be my only option here to do this problem? To factor this? I'm going to have to keep it like that. I can't get rid of that e. If I have a quadratic equation, what is the all-time fail-safe safety net type thing for solving a quadratic formula? Okay, in this case, what is a going to be? 1. What is b? 1. And what is C? Negative 2 minus E. Plug that stuff in, the opposite of B, so negative 1. Plus or minus the square root B squared minus 4 AC all over 2A. All right, so evaluating that negative 1 plus or minus. So we got 1 minus, okay, so now basically what's going to happen, I'm going to distribute this negative 4 to the negative 2 minus E, right? So negative 4 times negative 2 is positive 8, and then negative 4 times negative E is 4E. And that's going to give me negative 1 plus or minus 9 plus 4E all over, oh, I don't know why I put 1 there, it's 2. Okay, so that's what we're going to leave as X for the moment. Okay, some people ask, well, can I take that 9 plus 4E, because 9 and 4 are both perfect squares, right? All right, that is 3 plus 2. Is that allowed? Okay, so let's think about this then. So you're telling me that if I have radical 25 plus 9, underneath the radical, I can write that as, let's do it this way, 25 plus 7. I can write that as 5 plus radical 7. If I go, type that on my calculator real quick. So I'm trying to get at here is, you know, we might not remember an algebraic rule, but we should be able to say, you know, what do I want to do? I know I could take square root of 25 plus 7 on my calculator, and it give me 5.656. And I could take this 5 plus square root of 7 on my calculator, and it give me 7.645. And because those two numbers are different, this was not allowable, right? Okay. Going back to the 9 plus 4 idea. Okay. So some people are going to say, well, that's radical 13. Some people say, no, that's 5 because that goes to 3 and that goes to 2. Well, which one is right? If I type that in my calculator and type that in on my calculator, those two are going to be the ones that equate. The 5 is not true. Does that make sense? And the reason, so you cannot, because of this sum here, you cannot take the square root of 9 and the square root of 4. If it was a product, then have at it. But the sum, you cannot do that. So those are my values of X. Let's go ahead real quick. I think I've already typed this into, yeah, I've typed this into Desmos for us. And let's just do the plus version first. So negative 1 plus square root of 9 plus 4e over 2. Okay. I get my 1.7289 number. Okay. And then if I define that as X, you can see down here that it does indeed create the equation we started with, right? We get that 1 that we were looking for. Okay. So that's a solution. If I change this to minus, you get an X value of negative 2.7, but when I plug that in, what's negative 2.7 minus 1? Negative 3.7, right? Can I take a logarithm of negative 3.7? You cannot take logarithms of negative numbers, right? So that's why that one's undefined. Okay? Be undefined for the second one as well. Does this kind of make sense? How to work with logarithms? How to, if this was, just real quick, talk about this in the last class. If this was ln of x minus 1 minus ln of x plus 2 equals 1, what do you do with subtraction? What's that turn into? X minus 1 over x plus 2 equals 1. So now we would have e raised to the first equals x minus 1 over x plus 2. How do I solve that? Multiply by LCD, cross multiply maybe if you want to use it as a proportion, and then solve for x. That kind of make sense? Okay. There will be there'll be an exponential equation tomorrow, there'll be a logarithmic equation tomorrow, or Thursday. Yeah, probably Thursday. They'll be later in the test that I write, so. But they will be similar to the ones that we've seen in the last 2 days. Okay. Guys have any questions about the final? Remember, so the final, we get into the syllabus. Okay, your final is 1/4 of your grade. 2-hour block worth 1/4 of your grade. Does that make sense? Okay, so make sure that you don't just blow it off and say, it's just 1 day. Okay, because that equates to essentially 1/4 of 18 weeks, right? Okay. Make sure as you prepare, make sure that you run through that practice exam, maybe multiple times. I would even argue that the best thing you could do, if your person said, I can do this exam, it's taking me time, but I can do the whole thing. It takes you 3 hours to do it. Is that going to be good for you? No, because you're going to miss out on an hour, right? You're going to get halfway done, 2/3 of the way done, and get zeros on the rest of them. So I would time myself on this, okay? Make sure that you can do it in 2 hours. Okay? It's like an hour and 40 minutes. Okay. The 25 question version of the practice exam is what I've used in the past, and people have never, ever had issues with completing that in time. Okay? You guys are getting one that's going to be about 16 questions. Okay? So there should be, I think, if you know what you're doing, no issue in regards to getting that thing. Okay? You'll get half of it tomorrow, and that half will have to be finished in class tomorrow. And then you'll get the second half on Thursday. Anybody have any questions? Yes?
So what half do you overall cover in the first quarter? You did.
Roughly, yeah. I'm not going to give you like a date or anything like that in regards to what the first half will look like, but if you go through that practice exam, I'd probably go up the question 12 or 13. We probably maybe I would make sure that I'm aware of tomorrow. I don't know that I would prepare that way though. That say I'm only going to study for half of it tonight and half of it tomorrow, but it will be the structure of the exam is in order. It's chronological to how we progress through the year though, so that the first question will not be a logarithm. Yeah, I don't. That's. I have no idea. This is completely bizarre to me. Neither of them are what you're going to see tomorrow, like the number wise. So, let's see here. So what Lucy's saying is, like when I click on this, and it populates here. Come on. I'm going to mess around with this to see if I can fix it. I messed with it for about 5, 6, 7 minutes earlier today, and it won't change. This here, okay, you can see that there's nothing crossed out, right? Okay, and if you kind of keep track of the numbers, they are different than when I click download here, open up the PDF there. Now the numbers are different. And there are ones that are X'd out, right? Okay. what we've got going on here is actually, at one instance, the one with nothing crossed out was an exam at one point. Okay, it was the actual exam for a class. This one here I use as the practice exam for them. Okay, for you guys I would use this. Okay, I do the ones that are crossed, or use the one that's crossed out. But if you want more questions like that one, go into Schoology before it crosses them out and write that problem down. Does that make sense? Okay, you got another example that is similar to that. This is the one that has the X's crossed out, or the problems crossed out, because we didn't get to discuss rational inequalities. It's not a big topic. There's some stuff down at the end, like the whole last page, I believe, is crossed out. We didn't do series and sequences. That is no longer a topic that the state of Ohio requires higher education to cover in a algebra course, a college algebra course. You cover that in statistics, or not, you cover that in calculus. And then there's some stuff here with, I just took this one out. You guys can do that one. It's a system of equations, but I took it out. Conic sections, you guys seen a little bit last year. We didn't talk about this year. Take it out. Another topic that the state says is not required, college algebra. But all these other ones that don't have X's in them, you should prepare for those accordingly tomorrow and Thursday. Yes?
F composite G, is that when you put G into F?
F composite G. Yeah, G goes in F. So you work it backwards.
That's what I'm talking about.
Yep.